Today, we're solving radical equations graphically and algebraically. You've done this all in Math 20-1, the algebraic solutions, and probably some of the graphical solutions. But now we kind of tie it to how the domain's restricted because of the stuff we learned yesterday. It's all going to sort of come together in one big thing. What we need to remind you of, that this thing here is called what? Well, yeah, it's a square root, but it's also the radical sign. So more importantly, this is the sign that we use for radicals. We could have cubed root, fourth roots, 5 roots, but we just consider square roots for this course right now. And they're equations, so we're going to be solving things that are like this. The square root of x minus 3, I don't know, minus 3 equals 0. So we're saying what value of x, or values of x, would make this true. So this is all we're doing today. We're going to look at it algebraically first, then we're going to look at it graphically, because a lot of you are probably going to look at this graphically on your diploma exam, but just know there's always those great questions. Verify where the dude made a mistake. Okay, so here's the steps. Here's the review from grade 11 math. Review of algebraic solving. And we'll say this is Pre-Calc 20. And there was 3 easy steps. Does anybody remember what you have to do? If we were looking at that equation up here in green, does anybody remember how we were supposed to solve this? So suggesting move the 3. So in doing that, basically the first step is we want to isolate the radical. Okay, so we're going to isolate the radical. Second thing we're going to do, obviously after you have that, we're going to solve for x, or whatever variable's in the equation, but more often than not it's x. Then there's the one part that you all complain about, but it is not an option in radicals. Pardon? Well, we could state restrictions as well. We know that from our domain. But when we're solving this, the last step in solving radicals, we have to verify the solution. Verify the solution because in these, we have to reject any extraneous solutions. So algebraically, they're going to come out and look good, but when you go to verify it, you're going to identify it as something that isn't included. Okay, this is not an option. This isn't like in junior high when they said, you know what, and always check to make the left side equal the right side, and that was basically just them forcing you to check your work. Here it's not an option because it's going to identify things that algebraically came out as a solution, but then when you verify it, you realize it actually can't be. Okay, so it's not an option for these guys. Good, bad, indifferent. Let's go to actually start to solve this then. We're just going to say solve x minus 3 equals 0. So the example we had on the other page, we're going to follow those nice little steps. Mike suggests first we isolate that radical by doing what? Move this 3. So I'm going to add 3 both sides, and I get the root of x minus 3 equals 3. Great. Now, how do we start solving for x? Square both sides. So I'm going to say I'm going to take this thing to get rid of a square root. I square, but what I do to one side, I have to do the other. So I square this as well. So on the right side, I get 9. Left side, I get. Now, Mike wasn't here for this conversation yesterday, kind of here. We're not taking a square root here. This is a positive. So it's just, we're saying it's positive because we don't have anything else indicated. This is just going to leave us with x minus 3. So now we're just solving something that you could have done in grade 7. X minus 3 equals 9. What do we do?
X equals 2.
Let's try again. We're going to add 3. Recorded for all to hear, Zach. That was Zach.
I know.
X he knows.
I have it written down. I knew it was 12.
X equals 12. Now we've done step 1. We've done step 2. We better do step 3. And the verification, when you verify anything, always go back to the original equation that you had. Why would we go back to the original and not something within our solving process?
It made
Yeah, algebraically, you could have made a mistake somewhere else. So we always check back with the original equation. If we're going to put it in here, 12 minus 3, and then minus 3, we want to make sure this equals 0. So we got the square root of 9 minus 3 equals 0. Does that equal 0?
Yes.
Yeah, 3 minus 3 equals 0. 0 equals 0. This is verified. Therefore, Zach was wrong. It is x equals 12. Okay. I know, he says. Now let's... I won't include last names. But he sits with chaps. All right, here we go. Solve.
Jake Chaps.
Here we go. We're going to solve this guy. Huge change. Wow, this is big difference here. The root of x minus 3 plus 3 equals 0. Same thing. We're going to try to start isolating the radical. We just subtract x minus 3. We take away the 3 from both sides. And we get the root of x minus 3 equals negative 3. Then square both sides. So we square this, and now this is the important part. This is a negative 3 on this side. We have to square the negative 3. So it's negative 3 times negative 3, which equals a positive 9. Here we still have x minus 3. X equals 12. So we think. And then we're going to verify this. We're going to verify it back in the original equation. X minus 3 plus 3 equals 0. We're going to put in a 12 again. So 12 minus 3 plus 3 equals 0.
Oh, son of a...
This here. What's the square root of 9 plus 3?
6.
6 does not equal 0. Therefore, this answer here is not right. This is an extraneous solution. What does it tell me about this whole question? It's not that the question's wrong. It's not that the question is flawed. What does it tell you about this top thing? There's no value of x that'll ever make this equal to 0. So there is no solutions. The answer to this is that there's no solutions here. Now, if I asked you this little bit of an extension, take what you know. We're saying, you know what, there's no solutions. Great. We know there's no value of x that will ever make this thing equal 0. What does that tell you about the graph of this equation? Has no x-intercepts? What else? What if I graphed this stuff here in y1, this in y2? What does it tell you about those two graphs? They would never intersect. So if it equaled 10 or something like that, if this equaled 10 or equaled 7, if you're trying to look where they intersect, they would never intersect. Okay, so that's what it says graphically. All right, here's the next example. Solve the square root of 2x plus 7 minus x equals negative 4. I'm going to give you guys a few minutes to try to solve this on your lonesome using the same steps. It's a little bit different because when you move things to the right side, you're going to see something pop up. So give it a shot, and we'll come back and look. All right, let's start looking. It's the same steps here, guys. We have the radical. That's the 2x plus 7 as the radicand. All we got to start is the first step is add the x. And if you laid this out properly, I guess, or convention-wise, this turns out to be x minus 4 on the right-hand side. Not a big deal. Next step is to start to get that radicand out. That means we square the left side, but what we do to one side, we have to square to the other. So that unlocks the radicand. We get 2x plus 7. And then here you have to remember that x minus 4 squared is actually x minus 4 times x minus 4. So you FOIL or you do however you multiply those out. And we get x squared minus 8x plus 16. Now we have a quadratic. We want to just get everything to one side. It's called Harriot's principle. If you don't know that name, not a big deal. Move everything to one side. Move it to where our leading coefficient's positive. So in our case, we're going to move it to the right. So that means I'm going to take away 2x and subtract 7. So I got x squared. Now I have negative 8x. Take away 2x. I get negative 10x. And then 16 take away 9 is, or 16 take away 7 is 9. Then we got a quadratic. We want to start solving it. We should factor it. What does this right side factor to?
X minus 9,
X minus 1. Those are my factors, which means I basically have one factor x minus 9 equaling 0, and I have another factor x minus 1 equaling 0. So my two solutions that may come about through algebra at least are x equals 9, x equals 1. But we now have to go and verify that both of these solutions actually work. So my verification, the original guy was 2x, I was going to spell verify and I already had the C committed, 2x plus 7 minus x equals 4. We want to see if a 9 works in here. So 2 times 9 equals negative 4. Okay. That minus a 9, we want to see if that equals negative 4. So I have 18 plus 7, which is 25. What's the square root of 25? 5. So I got 5 minus 9 equals negative 4. Does that verify? Yep. Negative 4 is negative 4. Therefore, we know that this guy, x equals 9, is a solution. Say, Cole?
Is there a possibility that both of them would work, or a possibility that none of them would work?
Is there a possibility both would work? Guaranteed. That would mean that if we were to graph it, the left side of the equation, if we were to graph this left side over here, this stuff would intersect with this thing in two places. If there's one solution, it intersects once. If there's none, they just don't intersect. Graphically, that's what it means. Okay, we're going to verify 1, so we're going to go 2 times 1 plus 7 minus 1. We want to see if it equals negative 4. So here I get the root of 9. Minus 1 equals negative 4. Is 3 minus 1 negative 4? Not here. Therefore, this is an extraneous root, an extraneous solution. X can equal negative 1, or sorry, positive 1. We have one solution then. The solution is where x equals 9. Okay? One solution, x equals 9. We verified, we found one was extraneous. So this means these two things graphically only intersect in one spot. Here's the next one, which is kind of the title to this whole section. Solve x plus 3 equals the root of 12 minus 2x squared graphically. Then sketch it with appropriate window settings. Before we go on, some of you are entering it, what does appropriate window settings mean in the context of solving?
You can see all the
You can see all the intersections on these guys. Okay, you can see all of your solutions in the window. So go and try to get this thing in appropriate windows. All right, so get this into your calculator, put y1, y2, left side, right side, and then always start with your standard windows, so zoom 6, and if you look, I can see both intersections if there are two intersections there, so this is an appropriate window. So that's all you need to do to sketch this thing. Okay, put it in there. We can see that we have two places where we're considering these things intersect. Now, how do we find them? How do we find those intersection points? Yep, second trace or second calc. Number 5 is intersect, and then first curve, second curve, guess. One of the solutions, we can see that top one, is saying the solution is x is 0.414. So that's one of the solutions. X equals 0.414-ish. If you go and find the other one, who found it?
Yeah.
What is it, Mike?
X equals negative 2.41.
Negative 2.414? Is that what you said? Okay, here's my two solutions. Do I need to verify them? So Cole's saying yeah.
No, because they're rounded.
They're rounded. Okay, so let's start there. If they're rounded, would you expect the left side to exactly equal the right side? No, it should be decimals off. It shouldn't be hundreds or thousands off. It might be a little bit off because you're rounded. And the more decimals your solution has, the closer the left would equal the right. But I'm going to pose the question to you again. Do we need to verify it, Kelly? Yeah, we looked at it on the graph. The graph is saying these are the intersections. So graphically, I don't need to verify. They're right there. So our appropriate window settings are just the normal ones, and we just find the intersection points, and away we go. Is there another way you could have solved this graphically? This was one way. Left side equals right side, or sorry, left side. In Y1, right side in Y2, find the intersection. Is there a different way you could have done it?
Should have moved it all over to one side. That's 0 on the other side.
Yeah, move it all to one side, and then find where your x-intercepts are, and they'd be the exact same ones. That's more work, but doesn't matter. So that's it. Is this tough stuff so far? All right, we're going to put your assignment up here, and then that's what you're working on. If you weren't here yesterday, you should probably watch that video from yesterday because there's some interval parts in there, domains and ranges. Okay, I'll put the assignment up here in a